This is Learning Assessment Problem 319. The problem-solving strategy to be applied here is that of mesh analysis. We're asked to find the voltage V sub O appearing across this 2K resistor. In the mesh analysis approach, we're going to label some mesh currents. We'll call this I1 and this current I sub X, since that's the name that's already given up there. And then our auxiliary equation for the VO quantity will be 2K I sub X. We have a dependent voltage source at the left side of the circuit, which is 2000 times IX. The units of the 2000 will be ohms, so let's convert that to K. We'll have that as 2K IX for the strength of that current source. And that's a function of the mesh current in the right-hand mesh. So we can proceed to sum voltages around these loops. We'll indicate the polarities of voltage drops due to the currents in each loop or mesh. So we'll begin by writing a Kirchhoff's voltage law expression around the mesh I1. And we'll have 2K I1 for a voltage drop at the top of the circuit, plus 4K times the difference between the mesh currents I1 minus I sub X at the right-hand side of that mesh. And then to complete the loop, we'll have to add in the voltage of the dependent source, which is minus 2K IX. That all sums to 0. We can rearrange that and obtain 6K I1 minus 6K IX is equal to 0. And we'll call that our mesh current equation 1. Now we'll do a KVL around the mesh IX. We have a minus 12 volts for that independent source, plus 2K IX plus 4K IX minus I1 is equal to 0. Rearranging there, we have minus 4K I1 plus 6K IX is equal to 12 volts. And we'll call that our mesh current number 2. You can write these two equations in a matrix format. So that is the resistance matrix. Then we have the current matrix I1 and IX. And that's equal to the voltages 0 and 12 volts. So this would be from equation 1 and from our mesh current equation 2. This yields, since we're only interested in the I sub X current to solve the problem, we have IX is equal to 6 milliamps. And then we can use our auxiliary equation that VO is equal to 2K IX, which is equal to 2K times 6 milliamps, or VO is equal to 12 volts.